Hi boys and girls, Algebra, Lesson 1, Take 2. Hoping that the phone's not going to ring and no one's going to come in the door. So what is algebra? Algebra is simply advanced arithmetic. So if you know how to add, subtract, multiply, and divide, you too can do algebra. People get so worked up when they hear that word, like, oh no, I can't do algebra. Yes, you can do algebra. So let me give you just a really quick kind of demonstration. So you know how to add, multiply, divide, and the answer, like the sum, the product, the quotient, would be at the end of your equation. The only difference in algebra is that the unknown, or what you're looking for, is not at the end of your equation. It's usually somewhere in the middle. So yes, I said 23 times what gives me 345. If I said 128 divided by what will give me 32. These are examples of algebraic questions. Now, you need to know that when I'm speaking of addition, subtraction, multiplication, division, those are operations. That's what they're called. And algebra problems usually involve multiple operations. So you're not going to have just addition or just multiplication or just division in your problem. You're going to have them all mixed together. And that's okay because you're going to follow the rules of math. And the great thing about math is the rules don't change. They stay the same. So once you have the rule, you can use it forever. All right, so let me erase this. Okay, you're going to hear the word variable when you do algebra. What does the variable mean and what does it stand for? A variable stands for the unknown. It's the thing that we don't know that we want to find out. Now in algebra, this is where people, they'll make these comments. Well, when you start mixing the letters with the numbers, then you lose me. That shouldn't be the case because all that the letter stands for is the unknown. So if you see an X, a Y, a Z, a B, etc., when you see those letters in an equation, it just means that that is what we're looking for. We're trying to figure out what that is. So let's do a couple problems that might help you. So for example, if I have X plus 11 equals 33, we want to know what X is. And so this is a pretty easy one. You'd say 11 plus what will give me 33? Well, we know that 11 plus 22 would equal 33. So we'd say, 22 plus 11 equals 33. Our unknown, our variable then must be 22. There's nothing else that you can put there that you can add to 11 that will give you 33. Let's do another one. Let's say 13 divided by y equals 13. Okay, so there's only one correct answer here. Y has to be what? 13 divided by what will give you the same number? 1. So in this equation, y has to equal 1. The unknown is y. All right, one more. Let's say we have x minus, 1/5 equals 2/5. So you're thinking, well, at least we have the same denominators. Yay. So all I need to do is really look at the numerator and think, okay, what minus 1 will give me 2? I can work backwards. 2 plus 1 will give me 3. So let's try that. 3/5 minus 1/5 will equal 2/5. 3 minus 1 is 2. Yay. So my unknown here, x, is going to be 3/5. So in math, when you're doing arithmetic in the earlier grades and they say find the missing number, you're actually doing algebra because that's what it is. You're finding the missing number. So if you want to call algebra finding missing numbers, if that makes you feel better, go for it. Okay, let me erase this. All right, we're going to move on to properties or rules in math that you need to understand. The first one is called commutative. Commutative. Okay. Can't write today. All right, so commutative property, that just means that changing the order or direction, let me write that down, changing the order or direction of, yes son, do that, does not affect the sum or the product. Boom. Okay. Sum, that's addition, a little plus there. Product, that's multiplication, so I put a little X there. Okay, remember those. So all that means is commutative. Think of commute if I'm going to commute to work, right? It doesn't matter if I start at the 5 and go 7, I'm still going to get there, the 12 miles. Or if I start at someone else's house, I'm still going to get there. So what it means is it doesn't matter if the order of the numbers are switched. It doesn't affect the sum. You're still going to get 12 here. 12 equals 12, 5 plus 7, 7 plus 5. That also works in multiplication. So if I say 5 times 7, I'm going to get 35. If I change that to 7 times 5, I'm going to get 35. So addition and multiplication are commutative. And you need to know that when you're throwing in all those variables, those unknowns, and the numbers, and you have to know that you can switch them and it's okay. The order of them, you have to know that. So that's why commutative property is important. And I will tell you that subtraction is not commutative, and I'm going to show you that. So let's take 7 minus 5. 7 minus 5 equals 2, right? 5 minus 7 equals -2. They are not the same. Subtraction is not commutative. Let's look at a division problem. 7 divided by 5 will give you 7/5. 5 divided by 7 will give you 5/7. These are not the same. These are not the same. Subtraction and division are not commutative. Addition and multiplication are. And you have to know that going forward into algebra. All right, moving on to the next property that we're going to cover today, associative property. Now, associative property just means who I'm going to associate with. Who am I going to be more closely associated with? And so in addition, in this first problem, I'm going to associate 3 plus 5. And in the second, I'm going to associate 5 plus 7. So let's see if that changes our outcome, our sum. So here, 5 plus 3 is 8, right? And 8 plus 7 is 15. All right? But in the second problem, because I have parentheses first, and we're going to talk about order of operations in our next lesson, 7 plus 5, right? 7 is 12. And 12 plus 3 is 15. So addition is associative. Yes, addition is. Let's look at multiplication. So here, in our first problem, we're going to associate the 4 and the 5 together. 4 times 5 is 20. And then 20 times 6, see, 2 times 6 is 12 with a 0, equals 120. Let's look at the second problem. I'm going to associate the 5 and the 6. 5 times 6 is 30. 30 times 4, well, 4 times 3 is 12, and I bring along a 0. So addition is associative, multiplication is associative. Yes. Let's look at subtraction. Alrighty, we're going to associate. So the first thing I'm going to do is 10 minus 7. 7, 8, 9, 10, that's 3, okay? 3 minus 4, or 3 plus a negative 4, that's going to give you a negative 1. Then I look at this one, I'm going to associate the 7 minus 4. Okay, 7 minus 4 is 3. All right, 10 minus 3 is 7. These are not the same. The answer is not the same. So these are not associative. Subtraction is not associative. And finally, we want to look at division. Is division associative? When I associate these numbers, will I come up with the same answer or the same quotient? All right, 8 divided by 4. 4 goes into 8 2 times. 2 divided by 2 is 1. Let's look at this one. I'm going to associate the 4 and the 2 this time. 2 into 4 is 2. 8 divided by 2 is 4. These are not the same. Division is not associative. All right, so let's recap. In algebra, our advanced arithmetic, commutative property and associative property are true for addition and multiplication. Both are not true for subtraction and division. So when you are working problems in algebra, you have to know, oh, it's okay to associate these because it's multiplication. Oh, it's not okay to associate these here because it's division or it's subtraction. All right, so that's your first lesson in algebra. I hope that it will help. Bye.